Hello everyone, our project is titled Smart Purchase.
This is a supermarket. We can see how crowded it is. There is a long queue in the billing counter. Customers get stressed up and much time is lost. A solution to this problem, which is to reduce the billing time and increase the efficiency, can be brought about by using radio frequency identification instead of the conventional barcode billing. The main disadvantages of barcode billing are the barcode has to be in line of sight of the barcode reader. Only one barcode can be scanned at a time. Also, a high degree of manual work is being involved. All these can be overcome by using radio frequency identification. The RF tags need not be right in front of the reader. They just need to be within the reading range. Multiple RF tags can be read at a time. This process can be made fully automated, thus reducing human blunders. Now, let's see how this can be brought about in real time. In a supermarket, customers put their items in a trolley. There can be a setup like a gateway where the customers can pass through the gateway along with their trolleys. The RFID reader on the sides of the gateway will scan the RF tags on the items inside the trolley. Every tag will have a unique UID and thus every item is uniquely identified. The RFID reader scans the tag UIDs and they are stored in a file. The item details corresponding to each tag can be retrieved from a database. The retrieved item details are processed to generate the bill. This process of generating the bill can be made automated. The customers coming out of the gateway can collect the bill. Also, they can collect a carry bag to pack their things from a carry bag roller. This entire process can happen in very less time as RFID readers can read all the tags within the trolley at a time.
Now let's see the block diagram for scanning the tags, reading the tag information and generating the bill. TI component TRF7960A EVM, which is an RFID reader, is shown here. The RFID tags are target tags, which is also supplied by TI. The target tags are placed in the proximity region surrounding the RFID reader so that it could communicate with the RFID reader and the information from the tag could be retrieved using the RFID reader. The information retrieved from the tag is given to a computer, which in turn the information is processed and which is used to generate a bill using a printer. Now let's see the hardware demo. This is the TRF7960A EVM purchased from TI, which is a 13.56 MHz RFID reader. It contains an RF transceiver IC TRF7960A and an MSP430 microcontroller. Communication takes place between the RF transceiver IC and the RFID tags. Each tag contains a unique identifier number which is used to identify the tag and which is associated with each product in the supermarket. Now, the target tags are placed in the proximity region of the RFID reader. For instance, 4 tags are placed here. Now, these tags are read. The UIDs of the 4 tags are displayed here. Now, each product has a unique information and this is identified using the UID and these are stored in a database. Now we can see the log file which contains the communication between the RF transceiver and the target tags and the UIDs of the tags. Now the information is to be retrieved from the database regarding the products and it is to be billed. This is done by Microsoft Visual Studio software. These are the 4 products which are billed. And the bill will be generated. As you can see, this is the bill generated for the 4 products. This is the block diagram of the module 2 which is used for rolling out a carry bag simultaneously while the bill is being carried out. The TI components used here are TL084, DRV8811 motor driver IC and MSP430 G2553 microcontroller. DRV8811 and TL084 are the 2 analog ICs used here. And the microcontroller is MSP430 G2553. The basic concept is there is an IR transmitter which is placed on one side of the gateway and an IR receiver on the other side of the gateway. The rays are transmitted from the transmitter to the receiver. When the customer passes across the gateway, he will block the IR rays being received by the receiver, which gives a high output, which is not enough to drive the microcontroller. So we use a comparator TL084 in order to generate a high voltage output so that it can enable the microcontroller. This microcontroller in turn enables the motor driver IC DRB8811, which in turn makes the stepper motor to rotate a full step, and which is attached to a carry bag roller to produce an automatically rolled out carry bag, so that the customer, when he reaches carry bag counter, he can automatically correct the carry bag and move on. Now let's see the hardware setup for this module 2. TIIC components used here are TL084 comparator IC, the DRB8811 motor driver IC, which are the two analog ICs used here. The microcontroller used here is MSP430G2553. The basic functioning of this circuit is the input 230 volts main AC is being stepped down using a step down transformer, and it is rectified using this AC to DC voltage regulation, and the corresponding voltage supplies are given to the IR transmitter receiver part, the TL084 comparator IC, the DRB8811 motor driver IC, and MSP430. So when the voltage supplies are given, the IR transmitter starts transmitting the IR rays to the IR receiver. When the customer passes across the gateway, he will block the IR rays, so that the high output is generated, which in turn is given to the comparator to generate an even higher voltage in order to enable the microcontroller, which in turn enables the motor driver IC, so that it can make the stepper motor to rotate. Hence, a carry bag is rolled out, so the customer can collect the carry bag and pack his items. Now, the supply is switched on. The IR rays are transmitted from the transmitter. Now it is being blocked so that a high output is generated and the motor rotates.
Every invention will have its pros and cons. One of the main limitations of our idea is the cost of RFID readers and RF tags. Greater is the reading range of the reader, higher will be its cost. So is in the case of RF tags. Smaller and smaller the tags, higher will be their cost. Attaching big tags to small items like a pen or an eraser is practically not feasible. Reusable tags, they do exist, but they're not yet been fully exploited. And also, removing the tags from all the items after billing would only take time. Reduction in cost of RFID readers and RF tags would be a great boost for the real-time implementation of this idea. If we could get RFID readers and RF tags at the cost of barcode readers and barcode labels, then instant billing would just become a reality. Automatic identification and data capturing would be made great use of. Manual intervention would also be greatly reduced. Above all of this, getting the items billed, especially on weekends, would no longer be stressful. Happy shopping!